In this video, we'll look at question 84 from the 2016 exam. So in this question, a ball is thrown into the air with an initial speed of 8 meters per second, and it reaches a certain height h when it has a speed of 2 meters per second, so it's slowed down a bit as it's thrown vertically upwards. Then it reaches the top of the trajectory and comes back. And there are two quantities, which we are supposed to find. First of all, the height, which it is at when it has this speed, 2 meters per second, on the way up, and then the time it takes to get back to this height on the way back. So the time of this whole trajectory from when it's released to when it reaches the height h. And whenever we see anything with different speeds at different heights, that really sounds like we should use conservation of energy. So we'll set the gravitational potential energy to be 0 here at the bottom of the trajectory. And then the energy here at the bottom will be 0 from the gravitational potential energy plus the kinetic energy half mv squared. Just for clarity, let's call the speed v and the speed u. And by conservation of energy, this now has to equal half mu squared, the kinetic energy at that new height, plus mgh. And as the masses cancel, we can isolate h and get v squared minus u squared divided by 2g. And with the numbers, it's 8 squared, 64 minus 4, 60 divided by 20 is 3 meters. And to find the time taken to reach this height, we'll have to use one of our Suvat equations for the distance traveled during a uniformly accelerated motion, just with a slight alteration because quite unwisely I called the initial speed v instead of the traditional u, so now it's vt plus half at squared, but it's just letters. So our s in this case is 3 meters, the height, and that has to equal the initial speed 8 times t, like this, and acceleration is -10, so we're going to get -10 1/2 and t squared, which is a quadratic equation in t, like this. And this equation has two solutions, either 0.6 seconds or 1 second. And that shouldn't surprise us at all, because the height h, 3 meters, is reached twice, first on the way up, after 0.6 seconds, and then on the way back at time equals 1 second. And we're asked to find the second time, so 1 second is our correct answer. And along with 3 meters, that will give us option G.